During the 1960s, the U.S. space agency NASA was pursuing the Apollo lunar program. This was very ambitious for the time, but even more ambitious plans for space exploration beyond the lunar missions were being made. These included nuclear rocket engines and a crewed Mars mission. The feasibility of nuclear rocket engines was being studied as early as the mid-1950s, with actual research and development beginning in 1957. Conventional liquid-fueled rocket engines generate thrust by the chemical reaction and combustion of two propellants. In nuclear rocket engines, a nuclear reactor is used to heat a liquid propellant rather than via a chemical reaction, and a large quantity of chemicals is replaced with a small reactor. The propellant is usually liquid hydrogen. Because the energy to heat the propellant comes from the nuclear reaction rather than a chemical reaction, the propellant can be used based on maximum performance. Due to these factors, a nuclear engine has superior performance to a chemical engine, achieving at least twice the efficiency of a chemical engine. The basic design of a nuclear engine is like that of a chemical engine, in that each contains propellant in a large tank and pumps it into the engine's reaction chamber using a turbopump. A major difference, however, is that the reaction chamber is larger, the size of the reactor. By the early 1960s, initial nuclear engine tests were being conducted at a facility in Nevada, with engines not intended for use in space, proving the design of the engines. Those tests led to the Nuclear Engine for Rocket Vehicle Applications program, or NERVA, in which a prototype of a complete engine was tested. The first test was carried out in September of 1964, and further tests were conducted from 1964 through 1966, and all were successful. A more advanced engine, the NERVA XE, was tested between December of 1968 and September of 1969. During the period of testing, NASA had plans for NERVA to be used for future space exploration into the 1970s and 80s, including a Mars mission by the early 80s, as well as a lunar base and deep space exploration of the outer planets of the solar system. The Mars mission was proposed in 1969. The plan would have included a NERVA-equipped stage for use on interplanetary mission spacecraft. Development would have taken place during the 1970s, with the mission taking place by 1981. The mission would have been carried out by 2 ships. Each ship would have had a crew of 6. Along with the Mars excursion module, each ship would also have carried 8 probes, 6 from each ship for sample return from different locations on the Martian surface, and 2 from each ship sent into the atmosphere of Venus during a flyby of that planet on the return to Earth. Using 2 ships would have provided redundancy, where crew from one ship could move to the other ship if problems arise with their ship. It would also have increased the amount of hardware for exploration to equip the mission. The ships would have been assembled in Earth orbit. Components would have been launched into Earth orbit by Saturn V rockets, with supplies and other hardware being transported by space shuttles. Each ship would have been comprised of 3 nuclear propulsion units side by side, with the ship comprising the habitation module and the center nuclear propulsion module. Following assembly in orbit, the ships would be checked out and the crews would go aboard. After checkout in Earth orbit, the 2 spacecraft would have been boosted by their 2 outer nuclear propulsion units to trans-Mars injection velocity. The outer units would have been shut down and released from the ships and sent back to Earth orbit for reuse. Departure from Earth orbit to Mars would have been in November of 1981. Arrival at Mars would have been in August of 1982. Upon arrival, each ship would fire their nuclear engines to decelerate to enter Mars orbit. After arrival in Mars orbit, the sample return probes would be deployed to the surface first to robotically collect samples for return to the spacecraft. This would allow for the study of the samples to determine whether they posed a health hazard to the crew prior to sending crew members to the surface. Each Mars excursion module would carry 3 crew to the surface for a 30 to 60 day stay. The MEM would consist of a descent stage with living quarters and a laboratory, along with a small rover, and an ascent stage consisting of the control cabin, ascent engine, and fuel tanks. The descent stage hardware is left on the surface. There would be capability for one crew member to land an MEM to rescue a stranded crew. While surface activities are going on, the crews in the orbiting spacecraft would monitor the surface activities and maintain the spacecraft. After surface exploration is completed, the MEM ascent stage returns to the Mars spacecraft. After docking with the spacecraft, the crew will transfer from the MEM to the spacecraft and the MEM will be jettisoned. After the crews had returned to their respective ships, they would use the nuclear engines to boost the ships out of Mars orbit. The departure from Mars would have occurred in November of 1982. Further study of the samples collected would be conducted, along with preparations for the Venus flyby. The Venus flyby would have occurred in February of 1983. During the Venus flyby, radar mapping would be conducted due to the cloud cover obscuring the surface. Each ship would also release 2 probes. Both ships would have returned to Earth in August of 1983. The nuclear engines would be fired to slow the ships into Earth orbit. The ships would then arrive at a space station. After medical examination aboard the space station, the crews would be returned to Earth by a space shuttle. Each ship would be refurbished and readied for further missions later during the 80s, with the goal of a 50-person Mars base by 1989. Although tests of the nuclear engines were successful, no flight tests took place. Ultimately, the Mars mission was canceled along with the NERVA program in 1973 due to post-Apollo budget cuts, along with the planned space station, and the only post-Apollo crewed exploration projects that came to fruition were the Skylab space station in 1973 and the Space Shuttle, which flew from 1981 to 2011. Both the NERVA engines and the Mars mission would have been feasible with the technology of the period. Perhaps in the near future we might see a modern version of NERVA sending missions to Mars and eventually the rest of the solar system. Thanks for watching, and if you like this video, please hit like and subscribe. And remember, when the future was cool.